With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, the bob of a simple pendulum at rest is given a sharp hit to impart a horizontal velocity of under root 10 gl, where L is the length of the pendulum. Find the tension in the string when the string is horizontal and the bob is at the highest point and the string makes an angle 60 degree with the vertical upward, right? So let us first find out the tension when the string is horizontal. So when the string will be horizontal like this, so if you see it was having a velocity of under root 10 gl here, and after going up a height of L, it will have some velocity, let's suppose v1, right? So you can calculate this v1 by applying the work energy theorem. So here the only force who is doing work is gravitation, since the work done by tension will be zero, since the displacement of this bob is perpendicular to the direction of tension force, right? So I will write work done by gravity is equals to change in kinetic energy. Simple. So the work done by gravity, you could see mgl, since it goes up a height of L, right? So it will be change in kinetic energy. So I will write half m v1 square minus initial velocity, what's this? So just put this, and this m will get cancelled out, and you will get v1 square minus 10 gl is equals to minus 2 gl, right? So you will get v1 square is equals to 8 gl, right? So here the velocity will be under root 8 gl. We want the tension, right? So here this tension force will act as the centripetal force. So I will write T1 is equals to, let's suppose this is T1, is equals to mv square by L, right? Okay, so it is to be calculated when the string is horizontal, right? Okay, so just put the values. M by L into V square, it is this. So this L will get cancelled out and you will get 8 mg, right? So this will be the tension in the string when the string will be horizontal. And the bob, when the bob is at the highest point, then what is the tension, right? Okay, so let's see. So when the bob will be at the highest point, right? So if you see here, at the lowest position it was having a velocity this much. So again you can apply the work energy theorem, but this time it goes up by a height of 2L. So just as we wrote here mgl, so that mgl will be m2 mgl now. So if I write the work done by gravity is equals to change in potential energy, right? So work done by gravity is mg into 2L is equals to, yeah, so this is change in kinetic energy. So let's suppose here the velocity is v2 and here the tension in the string is T2, right? So I will write kinetic energy final minus initial. So you can see the final velocity is this. Initially it is under root 10 gl. So you can cancel out this m, right? And you will get minus 4 gl is equals to v2 square minus 10 gl. Simple. So from here you will get v2 square is equals to 6 gl, right? Okay, now we want the tension T2, right? If you see here, the mg and T2 both will act in downward direction and both will act as the centripetal force. The summation of both will act as the centripetal force. So you write this. So now you can put the value of v2 here to get the T2. So T2 here will be m v2 square by L minus mg, right? So put the value of v2 as 6gl. So if you will put the 6gl, you will get 6 mg minus mg, and that will be equals to 5 mg. So this will be the tension at the highest position. Now if you see the question, we have to also find out the tension when the string makes an angle 60 degree with the vertically upward direction. So now if you see the diagram, so this will be the position, and this angle will be 60 degree, right? Okay, so initial position was this. So this distance is L cos theta, that is L by 2, and this distance will be L, right? So you can see already this total distance is 3L by 2. Okay, so again we will apply the same work energy theorem. Work done by gravity is equal to change in kinetic energy, but this time the work done by gravity will be equal to mg into 3L by 2. You could see already. And let's suppose in this position the velocity is v3, so I will write m by 2 v3 square minus initial velocity square, that is 10 gl, right? So you can cancel out this m, right? And this 2 will also get cancelled out, so you'll get 3gl minus 3gl plus 10gl, that will be v3 square. It will be 10 minus 3, it's 7gl, right? Okay, so we got the velocity at this position. If you see, the mg is acting downward and tension is acting in this direction, and this angle is 60 degree. So we could write the net force toward the center is T plus mg 60 degree is equals to mv3 square by L. Okay, so just put the value of v3 square and L. So this is the T3. So you'll get T3 is equals to mv3 square is this minus mg cos theta. So this is, yeah, so mg cos theta I will subtract. Yeah, that is cos 60 degree is half. So this L will get cancelled out. So you'll get 7 mg minus 0.5. So it will be 6.5 mg T3. So we got the tension in the string at 3 position which we were asked in the question. If you see, in the first part we got the tension T1 is equal to 6 mg, 8 mg, and in the second part we got the tension 5 mg. In the third part we got 6.5 mg as the answer respectively. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.